A revolution in the EV world. Sweden's new sodium-ion batteries are here, and it's a game changer. Could this be the end of traditional EVs as we know them? And how will this groundbreaking technology affect the industry? Come and let's find out more about this amazing new tech for EV batteries. Sweden's most recent development in the field of electric vehicle batteries has created quite a storm in the industry. This innovation comes from HyperVolt, a company that's been working on creating a more sustainable and cost-effective battery technology. Their latest product is a sodium-ion battery, which is hailed as a breakthrough for several reasons. Sodium-ion batteries offer a sustainable and eco-friendly alternative to traditional lithium-ion batteries, which rely on costly and environmentally damaging materials like lithium, nickel, graphite, and cobalt. In contrast, sodium-ion batteries make use of widely available and naturally occurring sodium, which significantly reduces the environmental impact of battery production and lowers the cost of battery technology. Energy density is a crucial factor in the performance of electric vehicle batteries, as it determines how much energy can be stored within a given space. HyperVolt sodium-ion batteries boast an energy density of over 160 watt-hours per kilogram, which is lower than the average lithium-ion battery, but is still a significant milestone for sodium-ion technology. This makes sodium-ion batteries ideal for large-scale energy storage, which is necessary for balancing the electricity grid and facilitating the integration of renewable energy sources. With its superior energy density, HyperVolt's sodium-ion battery is poised to revolutionize the battery industry and pave the way for a more sustainable and eco-friendly future. So what makes the sodium-ion battery unique? Well, it does not use critical raw materials. This is a game changer because it reduces the dependency on specific parts of the world, particularly China, which currently dominates the market for these materials. By avoiding critical minerals, HyperVolt's battery technology could help Europe and other regions become more self-sufficient in their battery supply chains. And what about the potential for electric vehicles? While the sodium-ion battery's initial design is intended for electricity storage plants, there is potential for its use in electric vehicles in the future. The technology could be particularly useful for smaller EVs, such as two-wheeled scooters, where the slightly lower energy density is less of an issue. This opens up new possibilities for the EV market, offering a more affordable and environmentally friendly option for consumers. Despite the promising features of the sodium-ion battery, there are challenges to overcome. The technology is still in its early stages, and further development is needed to improve the energy density and performance to match that of lithium-ion batteries. Additionally, the manufacturing process and scalability of sodium-ion batteries needs to be addressed to meet the demands of the EV industry. HyperVolt has not yet decided where the battery will be manufactured on a larger scale, but the prototype has been developed in their labs in Västerås, Sweden. The company plans to showcase the battery to consumers in the coming year, which will be a critical step in determining its commercial viability. The development of sodium-ion batteries by HyperVolt represents a significant step forward in the quest for more sustainable and cost-effective energy storage solutions. Its potential to reduce dependency on critical raw materials and its suitability for large-scale energy storage is particularly noteworthy. As the technology matures, it could play a vital role in the transition to a greener and more resilient energy system, as well as the evolution of the electric vehicle industry. The industry eagerly awaits further advancements and the eventual integration of sodium-ion batteries into the market, which could even revolutionize the way we think about energy storage and electric mobility. So, what is a sodium-ion battery? It works similarly to a lithium-ion battery. In both types, ions shuttle between the cathode and anode. However, sodium-ion batteries use sodium iodes, which are larger and have higher requirements regarding structural stability and the kinetic properties of materials. This has been a challenge for the industrialization of these batteries. Sodium-ion batteries boast a wealth of advantages, including their abundant and globally distributed resources that can facilitate production scalability, a cost that is approximately 30% lower than their lithium counterparts, making them a more economical choice for various uses and enhanced safety due to their resistance to lithium dendrites. However, they do have some drawbacks, such as lower energy density, which restricts their energy storage capacity and suitability for high-energy applications, a shorter lifespan compared to lithium-ion batteries, and a still maturing industrial chain that presents challenges in component availability, manufacturing, and recycling processes. In Sweden, a company named Ultris has announced its first industrial-scale cathode material production facility for sodium-ion batteries. They aim to produce 2,000 tons of phenate cathode material annually, which is enough for 1 gigawatt-hour of sodium-ion batteries per year. Production at the facility called the Ferron plant is expected to start in early 2023. This is a significant step towards the industrialization of sodium-ion batteries. While sodium-ion batteries present several advantages, such as abundant resources, cost advantage, and safety, they also come with notable disadvantages like lower energy density, a short cycle life, and an incomplete industrial chain. However, with ongoing research and development, these challenges are expected to be addressed, making sodium-ion batteries a viable alternative to lithium-ion batteries in the future. So, what's the difference between lithium-ion batteries and sodium-ion batteries? Lithium-ion batteries are currently the most common type of rechargeable battery used in EVs. They're known for their high energy density, which means they can store a large amount of energy in a relatively small space. This is crucial for EVs, as it allows them to travel longer distances on a single charge. However, lithium-ion batteries have some drawbacks. The main one is the high cost of lithium, which makes these batteries expensive to manufacture. Additionally, lithium is not evenly distributed across the world, which can lead to supply chain issues. In the case of sodium-ion batteries, a newer type of rechargeable battery is being researched as a potential alternative to lithium-ion batteries for use in EVs. The main advantage of sodium-ion batteries is that sodium is much more abundant and cheaper than lithium. This could potentially lead to lower manufacturing costs for these batteries. Additionally, the production of sodium does not involve the use of toxic chemicals, making it more environmentally friendly. However, sodium-ion batteries currently have a lower energy density compared to lithium-ion batteries. This means that EVs powered by sodium-ion batteries may not be able to travel as far on a single charge. Furthermore, the technology for sodium-ion batteries is still in its early stages of development, and there are challenges related to the availability of components, manufacturing processes, and recycling methods. EV batteries have been evolving from the start, so how has the EV and its battery tech evolved? Solid-state batteries are a revolutionary advancement in electric vehicle battery technology. They employ a solid electrolyte instead of a liquid one and offer several benefits over conventional batteries. These batteries can potentially store more energy within a compact design, which could significantly extend the driving range of electric vehicles. In addition, solid-state batteries offer faster charging times and are less prone to the risk of fire. Battery technology has recently made a remarkable breakthrough by incorporating silicon into the anode, the negative electrode of the battery. Silicon has an exceptional energy storage capacity, surpassing the traditional graphite used in batteries. This breakthrough could lead to batteries with a significantly higher energy density, improving their performance and efficiency. Is integrating silicon into batteries safe? Integrating silicon into batteries poses a durability issue due to its tendency to expand and contract during charging and discharging cycles. Researchers are currently working on addressing this challenge to unlock the full potential of silicon batteries, which could revolutionize the industry. Even though the batteries for EVs are rapidly evolving, we're looking forward to the process of recycling. As electric vehicle usage continues to increase, the importance of battery recycling cannot be overstated. Sweden's new sodium-ion battery is turning the game. But has it really ended the era of traditional EVs? And what does this mean for the future of electric vehicles? Comment your thoughts below, and don't forget to like, share, and subscribe for more.